Hello. Let's see. Okay, should see the desktop now. Does everybody hear me? Does everything seem okay?
Yes.
Okay, great, thanks. All right, so let me pull up a couple windows. Okay, still people coming in. Okay. Um, let's see. Today we're gonna start talking about these loops. Okay. Um, there'll be a programming assignment up real soon. Um, if you might even check over the weekend to see if a programming assignment appears there. Whenever it goes up, it won't be due for a couple weeks, but I might get it up. I'm going to try to get up there as soon as possible so you can at least get started on it. But uh, so you might look to see if it appears there over the weekend.
Pepper?
Oh, pardon me?
Sorry, that's my cat. He's stepping on my
Oh,
keyboard.
and remember, remind me. Monday and Tuesday are fall break, correct? Does anybody check? I think Monday and Tuesday are
Yes.
fall break. Yeah. So we will meet again a week from today. Yeah. So let's see. So the 12th and 13th are fall break. So we won't meet on Monday. So we'll meet a week from today. Okay. So have a nice weekend after this weekend. We have a longer weekend. All right. And let's see. Here's some more reading about loops. Okay. Give you a heads up. This is one of the hardest things we're going to cover right here. The whole course, nested loops, is one of the most difficult things. Okay. So we'll approach that. That's not going to be a half a lecture. That we're going to probably spend a whole week on that. So it really makes us think real. Nested loops are going to make us think real hard. Okay. So that's going to be one of the hardest things we're going to do. Okay. So that'll be next week. And yeah, we've been talking about if statements, and the last thing we did on Monday was string comparisons and a little bit more if statements. So we were talking about this stuff with what does it mean to use this on a string versus this on a string, and you aren't supposed to use this on strings. You're supposed to use this. Okay. So we are talking about strings and also if statements with logic. I picked several problems from Coding Bat that are nice logic problems involving strings. Okay, so these are pretty nice, simple, but a little bit challenging. Not super hard. They're not as hard as say a homework assignment is, but these are nice little problems. You can solve all of them probably in 5 lines of code, but they do take some. They're not trivial. You have to think about it. They're good practice. I am out of all these problems in the way this works. These are warm-up problems. Warm-up problems have the solutions, so they're good ways to get used to how Coding Bat works. String 1 are easier than string 2. Okay, string 1 don't need loops, which we're about to start talking about. String 2 do need loops, plus they're just a little bit harder problems. And then there's these logic problems here. Now, so these logic problems are easier than these logic problems. See, these are medium hard problems. Okay, so now in here, there's quite a few problems, and I picked the ones I thought were the most interesting, that use a little bit of logic to them. Some of them don't need any logic. Some of them are actually pretty darn easy. They don't need any if statement or any logic. So I picked the ones that need an if statement. So in this list, I picked the problems that need to use an if statement and things involving string methods and Boolean logic. Okay, so try those. Uh, uh, do one each evening. That's as good a way to study as any is to do these problems. If solving one of these each evening is really invaluable. More so than rereading the book, because when you do one of these, if you can do it right off the bat, you probably don't really need to be rereading the book. If you can't do them, then you know that you need to reread something in the book, and you have to look up what it is that you might need to do these problems. Okay, so they're really there's a lot of value in solving these. And if you have questions about them, you can send me an email. You can always ask me about doing one of these problems. Okay. So I picked out what I thought were the most interesting problems out of that section on the beginning string problems. And I'll probably pick some of the basic logic ones too. Later on, pick some of these logic ones. And those two sections there summarize the whole last chapter of what we did. If statements involving strings and just Boolean logic. These ones are just mostly just logic with a little bit of if statements. Okay, a lot of times these just ask for an answer. Is it true? Is something true or false? They're just logic puzzles, but sometimes they're asked for if statements for you to print out something. If one thing is true, print out something else if something else is true. So those are nice startups. We won't be able to do these problems for a while. See, these problems are harder and they involve loops. So after we've done the stuff on loops, then we can start doing problems from this section. And then the next chapter of the book, which we won't get to for another couple of weeks, is on arrays. Okay, so so notice that this follows kind of the order that we've been doing things in our book, because most books start this way: strings, logic, loops, then arrays. Okay, so right now the problems you can do in this are the warm-ups, the string one and the logic one. You should be able to do any of those, but I try to pick the ones I think they're most interesting. And after we've done a little bit about loops, we can start doing these string problems. Okay. If you notice, the reading assignment was, let's see. Oh, here, see, for next week, loops and strings. Okay. See, the reading assignment for next week is loops and strings, and Coding Bat has a whole section on strings with loops. See, loop and string problems with a loop. Okay, because that's such a common pattern. So, Coding Bat has a whole section just about exactly what this section here is about. Okay, so after you read this, if you want, you might go look at some of the problems in this section. Like, just start with the first one, give it a try. Practicing these problems is really useful. The problems in this book are very similar. They work together. Actually, the people who wrote this book, and the people who create Coding Bat work with each other. They know each other. They work together on things. So some of these problems are very Coding Bat-like, but they don't have this nice system that Coding Bat does, where you can solve a problem and get it tested. Okay, so look at those problems. Just do them. Just try doing them one at a time. Okay. Okay. Now let's look at it. Okay. So anybody have any question about that? Like what we did on Monday? Any question about stuff we've done so far? Any question that's come up? We took the test last week. I hope they'll give you the test back after spring break or fall break. Okay, so I hope next week I can give you the test back after fall break. Okay, now let's look at a problem. Let's look at an example. Let me start code Dr. Java. Okay, this problem is actually what we were doing. This is an example of what we were doing yesterday. Just compound Boolean expressions. Okay, so let's just look at this example just real quick. This one's going to create a scanner, prompt the user for a number, ask the user for a number, then read in their number. Okay, so create the scanner, prompt the user, read a number. Then I want to evaluate these 1, 2, 3, 4, 5 Boolean expressions. So I wrote them here so you can see which ones I want to evaluate. Is the number less than, is the number they typed in, see I called the number n when they read it in, is it greater than 10 and less than 20? Is it between 10 and 20? True or false? Is it strictly less than 10 or strictly greater than 20? Is it to the left of 10 or to the right of 20? Is it not less than 100? Okay, so is it essentially not less than 100 means same thing saying, is it greater than or equal to 100? Okay, so I've got these expressions. So what down here says, it tests each one of those. The expression, blah, 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 is, then it, see, notice here, I type the expression in a string so I can let the person who sees the output know what I'm evaluating. Then I type the expression as Java code. See, that's code, that's string. And here you can see it's color coded, red for string, and white. Notice how numbers are in yellow, but constants and variables are in white. Okay, so it just evaluates those strings, and then the program ends. Okay, so if I compile it. Okay, and then I'll run it down here. Okay. I'm going to type in my number. I'll type in 54. Okay. Oh, that's interesting. The color choice down here is not so great. I wonder if I can fix that. Okay. Okay, and then there's those outputs. I type 54. Is 54 greater than 10 and less than 20? Well, that's false. Is 54 less than 10 or greater than 20? Yeah, that's true. Is 54 less than 100? That's true. So take the opposite of true and you get false. Okay. Is 54 25? No. Is 54 75? No. So I don't have either the false. Okay. Now here's the question. What if, now notice that I just did that one time. What if I want to keep doing this? So here's a question that brings up loops. This is a good example. I'm doing something once, and I really want to do it a bunch of times. Why can't I just let the person keep typing in numbers? So how do you make something repeat? Okay, so let me show you that it's a real simple thing. We use something called a while loop. Now I don't want to repeat this line of code. I only want one scanner. I can keep using that scanner. So after I make the scanner, I'm going to type a line of code that looks like this. While, I'm going to write the word true here. Now the way while works is, it's like an if statement. If this was if, okay, let me close, I had an opening brace, so there's the closing brace, okay? And since I put these things in braces, I should indent better. So I'll indent. Now, Dr. Java will do the indentation for me. If I highlight this part that needs to be indented and hit the tab key, Dr. Java indented it for me. Now, Dr. Java will do these indentations for you if you ask it to. Okay. All right. So now it's indented properly. Now if I write if true, we know what that means. Well, if checks what's in here. If it's true, if what's in here is evaluates the true, you do this. If it evaluates the false, you skip. Okay. So this is just like my program. Well, this will ask one time. And if I run this, it'll ask me for one number. There's my number, 33, and there's my output. Okay, so it did it one time. Okay. What if I put the word false in here? What happens now? What does my program do if I compile it and run it? What will this program do now?
I mean, if the answer is true or what the person puts in is true, it won't do any of that.
Oh, no. No, careful. No. The user types in a number down here. What does this do?
It doesn't let it go to that because it's false.
Yeah, it skips this. So what does the program do now if I run it?
Nothing.
Nothing. Yes. Yeah. I compile it, run it, did nothing. It ran it. If I want to verify that it did nothing, watch this. I'll show you a way of making sure it did nothing. Here's a little opening statement. give my program a little opening statement, and give my program a little closing statement. Okay. So print the opening statement, execute this, print the closing statement. But this says false, if false. Well, false is always false, so it's going to skip over this, so my output's just going to be hi, bye. Hi, bye. The if statement got skipped. If I put true here, now run it. Okay, there's the opening statement. Hi, this is true. I'm in here. I'm doing this once. Here's my number, 67. Hit enter. There's my output, and there's my goodbye message. Bye. The program ran one time. Okay. Now, let me change this word if to while. While, what it does is kind of like if. If this is true, you do what's in here. But then you go back and do it again. You keep checking this thing over and over again. Now later we'll put something in here that's going to be sometimes true and sometimes false. That's what we really want. But right now, what this is doing is saying, while true, this is going to loop forever and just keep prompting the user forever. So what if I run this? Java is real clever. Java noticed that I wrote something that never stops looping, and it said you can't even get to this line of code, so it actually won't let me compile this program. It actually figured out that I never get to line 36 because this thing is true. I go down to the bottom, come back to the top, go down to the bottom, come back to the top. So if I want to see this work, I'll just get rid of that line there for now. So compile this. Okay, now this is going to keep, now if I run it, okay, it asked me for a number. Let me show more output. It asked me for a number, 2. There's my output. Asked me for another number, 6. There's my output. Asked me for another number, 700. Okay, notice it's going to keep on doing this forever. Okay. Right now, my program is asking me for a number. It's printing out this message, asking me for a number, doing these calculations, gets to this brace. The brace says go back up to here, check if this thing is true, but of course true is true, do it again. Get to the bottom, go back up here, check if true is true, of course true is true, true is true, do it again. Okay, all right. So the program is looping. So now I have this program asking the user can type as many numbers as they want now. The program is going to keep letting the user type numbers. Okay. Okay. Now, how do I get out of this? My program isn't going to ever stop. Have you had this problem? Okay. What do you think I might do? Look at Dr. Java. Anybody see a suggestion on what I could do to get out of this?
You can do a break statement.
No. Break is part of Java. My code is running. I can't go up here and do anything. How do I get out of this? My code is running. How do I stop it? This is a Dr. Java question. Dr. Java is running my program. How do I get it to stop running my program? Look at the interface. Anything look helpful for maybe getting Dr. Java to stop this from running down here?
Somebody said reset in the chat box.
Oh, yeah, great. Yeah. See, now you look up here and you see there's a thing called reset. Okay, try it. Are you sure you want to reset? Say yeah. And notice it stopped it. That's what it does. It stopped that program. Reset is, now that we're into the loop world, you could easily write a loop like this that just never stops. Okay. And if you do happen to write a loop that never stops, Dr. Java will let you use reset to stop it. Okay. So let me write a real dumb little program. I'm going to write
You misspelled public in your first line.
oh, okay. What's this dumb program going to do?
It'll just keep printing out the word hi.
Yeah. For how long?
Forever.
Forever, until I tell it to stop. So, okay. See, it's just printing out more and more highs down here. Okay. Now, actually, it will not run forever. Something will eventually give out. Yeah. The computer, if you, the computer is going to end up getting overloaded. Maybe maybe if I wait a few days, it might fill up the computer's memory or something might go wrong. Okay. So it's possible that Dr. Java will crash or something after a long time because this line is just getting longer and longer and longer. Okay. Now, if I'm stuck like this, yeah, I'm stuck like this, and this is going to happen to you. You're going to get stuck like this. You go up here and hit reset. Okay. And that fixed things. Okay. If I change this to an LN, pretty much not much. Now it's just a tiny bit different. Now it's printing out them as going vertically instead of going horizontally, but it's just going to keep printing them forever and ever. Okay. And you know, how do I get out of it? Reset. Stop the infinite loop. Okay. It's not hard to write infinite loops. You know, you can see it's real easy to write an infinite loop. Here I purposely did it, but later we'll see that you could write something in here that isn't really what you wanted. You make a mistake. You make a mistake in here and you end up with an infinite loop. Okay. All right. Now, what can we do to make this more reasonable? What can we do to make this ask? Let's see. Let's suppose we think it's reasonable to ask people to enter 5 numbers. Okay. So here's how I can ask somebody to type in 5 numbers. I'll have a counter that's going to count how many times that I've asked them for a number. And I want the counter to be less than 5. And I'm going to start with the counter equal to 0. But I have to declare it. So I say create a counter started at 0. While the counter is less than 5, do all this stuff. Then down here, I'm going to say, well, I just asked them for a number. So I'm going to make the counter equal to the counter plus 1. I'm going to make the counter count. Okay. Okay. This is now now we're doing stuff that's not dumb. Now we're writing a useful kind of while loop. I want to do something, in this case, 5 times. Okay. So I start my counter at 0. I check that it hasn't gotten up to what I want to stop at. And then down here, I say, well, I've done one of my loops, so let me increment the counter. Okay. Now what's going to happen is I start with the counter 0. 0 is less than 5. That's true. So I do all this. Counter becomes now from 0 plus 1 is 1. So counter becomes 1. Go up here to here. And now check counter is less than 5. Well, counter is now 1. 1 is less than 5. Do all of this. Increment the counter again. Okay. And so I should end up with, now here's the question. Am I going to do this 5 times, 4 times, 6 times? Okay. The first time I come here, the first time I have a 0 for while. Okay. Then while is 1. And then I'll do what's inside here. Then while is 2. And I'll do what's inside here. then while is 3, and I'll do what's inside here. And while is 4, and I'll do what's inside here. Now, while is 4, go down here. 4 plus 1 is 5. So now I come back up here, and while is 5. Is 5 strictly less than 5? Is 5 strictly less than 5?
No.
No. So I do not do this again. Now, how many times did I do what's inside here? 1, 2, 3, 4, 5 times. These were the numbers that where I did the inside, and that when counter became 5, I didn't do what was inside. Notice the counter took on 6 values, but I did what's inside here 5 times. This kind of stuff makes actually loops a little bit trickier than some people really realize. It's real easy to get goofed up in how many times your loop is doing something. So for example, suppose I did that. How many times does my loop loop?
6.
6 times. Okay. Now I'm asking the user for input 6 times. How many times am I asking a user for input now?
5.
5 times. See, now I start with counter is 1. 1 is less than 5. Then go up here and you get to 2. 2 is less than 5. Then you get to 3. 3 is less than 5. And then counter becomes 4. 4 is less than 5. Then counter becomes 5. 5 is less than or equal to 5. So you do another input. Then you get to 6. Oh, but 6 is not less than 5. Now notice the counter still takes on 1, 2, 3, 4, 5, 6 numbers, but I only do what's inside here 5 times. Okay. Counter takes on 6 values. It almost looks like you could say it's looping 6 times, but it's doing what's inside here only 5 times. Okay. So it did what's inside there when counter was 1, 2, 3, 4, and 5. Then counter had to become 6 to stop this. So this last value of counter didn't cause me to do what's inside here. Now, what's interesting is I'll print out what counter is. My little by message is going to say what the value of counter is. Okay. So let me compile this. Run it. Okay, there's my hi message. Enter a number. I'll enter a number 34, 45, 56, 57, 78. Oh, see now I finished. I did my 5 numbers. Now notice that by with counter 6. There was 1, 2, 3, 4, 5 inputs, but I ended up with counter equals 6. Okay. Now if I change it back, now go back here to where this was starting at 0. This was strictly less than 5. Compile this one. I'm still going to be asking the user for 5 numbers. There's a number, another number, another number, another number, another number. Oh, see, now I ended up by with counter equal 5. Okay. But counter started at 0. Now counter went 0, 1, 2, 3, 4, 5. The other time it counter went 1, 2, 3, 4, 5, 6. And both have the effect of giving me 5 loops through here. Okay. All right. So this is our basic loop. There's going to be 2 loops in Java. What's called a while loop and what's called a for loop. The while loop just says while Boolean do this. That's all there is to it. Okay. Okay. The while loop's real simple. While, if this thing is true, you do what's in here, then you go back up here and you check if this is true, then you do what's in here if it's true, and if this thing is false, you go down here. Now let me write that as Boolean expression, because it's really a whole Boolean expression. Now, what's going to make the, now suppose, how will this loop ever end? Suppose Boolean expression is true. What will stop this thing from being an infinite loop? Kind of an abstract question. How could this thing, suppose Boolean expression starts out true. How could this, what's going to stop this thing, or what could make it go on forever? What's a key idea? See if you can figure out a key idea here. It might go forever, but I really don't want it to. I probably want it to stop. What do I need to, what will make it stop?
Only a false statement for the Boolean expression.
Okay, but how do
So
I get
user
that?
input changing?
Well, there may not be any user input. Think, okay, you're on the right track. Okay, this has got to become false. But so what can you tell me? I wrote while Boolean expression do this. What can you tell me is concretely to get this thing
Not-
to stop?
After the statement, you could say, so you call a statement, and then after that, you could say Boolean expression is assigned false, and that will
Well, okay,
break out of, no?
right. So you want to, something has, so what can you tell me? Do this. What must be part of doing this? See, I wrote while Boolean expression do this. And I want this thing to virtually end. So what can you tell me about this? What has to, yes, exactly. Do this has to make a change to that Boolean expression. Somewhere, this is going to be a bunch of code. Do this is going to be a block of code. Somewhere in that block of code, I better be changing this value. If this value doesn't appear anywhere in do this, then it never changes. So when you write a while loop, you test something up here. It has to be the case that somewhere in your while loop, you modify what you're testing up here. That always has to be the case. Now, it could be you get some user input, but user input is not actually all that common in real computer programming. The vast majority of computer programs do not communicate with any person. The vast majority of computer programs communicate with other computer programs, or they communicate with pieces of hardware like steering wheels and brakes and engines and dials and meters. And I mean, like 99.99% of the programs out there, there is nobody communicating with the program. The program actually communicates with other programs. Okay, but somehow this program has to make a change in Boolean expression somewhere in do this. So somewhere in that code should be something that updates. Usually we think of it as an update. Something will, though you'll do something down here, you'll update this Boolean expression and go up and ask, am I supposed to do this again? Then you do this stuff again. As you're doing this, you're going to do something to update this Boolean expression, because if you never update the Boolean expression, then you have an infinite loop. Just like we did here, if I put true, see, nothing changed that. Okay. Now, on the other hand, if I want to print out hi 27 times, I say something like, and I can say, well, if the counter is greater than or equal to 1, keep looping. And then down here, I'll say counter equal counter minus 1. Okay. Now, here's the piece of code that made some change to what's in here. See, this thing asked, is the counter larger than 1? Down here, I made a change to counter, so that affected what's in here. So now this thing will loop. Oh, oh, this one I have to save it. I'm sorry. So Actually, I have to close it because it won't. Remember, I can't compile these things. Like I wanted to make dumb. I want to recompile dumb. I can't because while isn't a legitimate program. Dr. Java has this quirk that when you compile one program, it compiles all of them. I've mentioned it a couple times before, and I really wish it didn't do this. But I want to compile dumb, but I have to compile while. But while is just I was writing this thing here. So what I have to do is close that one. Now I can compile. Now I'm actually going to compile both of these when I click compile. Okay. Oh, what did I forget? What's wrong with line 5?
Should it say int
Yeah, I
counter?
forgot to declare counter. I forgot to declare it. I have to. It's the first time I've used it in the program, so I have to declare. I have to declare it. Okay. Now I've got 27 highs down here. Okay. Right. So the while loop, the what we call the body of the while loop, what goes inside the parentheses. This is the body of the while loop here. Okay. The body of the while loop needs to do something to update this Boolean expression. And if it doesn't, that's an infinite loop. And as programs get more complicated, it's actually kind of easy to make a mistake where you forget to do something in your body that updates the Boolean expression. Maybe you change the name of a variable up here and forget to change the name of the variable down here. Then you compile the program and run it, and note this one's not updating this one anymore. It's updating something else. It's really easy to get goofed up and get infinite loops, and that's when you use the reset button. Okay, we call this the body of the while loop. The body of the while loop better update the Boolean expression. Okay, okay, and if it doesn't, then you will have an infinite loop. Okay. All right. Now notice here I counted down. Over here I counted up. Doesn't really matter which one I do. I had a counter. I could count down. I could count up. Doesn't really matter. Here, I just wanted to count 5 times. I wanted to do this thing 5 times. Here, I wanted to do something 27 times, and I chose to count down. This thing can get messy. Like if I don't remember which one I'm doing, if I'm like suppose I get goofed up. Here's a good way to get goofed up. Counter is 27. Counter greater than or equal to 1. Counter equals counter plus 1. Okay, so I forget that I'm supposed to be counting down, and I count up. And I compile this and I run it, and now I'm in an infinite loop because I got mixed up. I forgot that I meant to be counting down, and I actually counted up because sometimes I count down and sometimes I count up. Sometimes it's convenient. No, I have to reset this. Sometimes it's more convenient to do a count down. Sometimes it's more convenient to do a count up. Okay, there's no rules about these. Sometimes count up works better, sometimes count down works better, but since there's 2 ways to do it, it's easy to get goofed up. You start off thinking I'm going to be counting down, then you forget and you get down here and you do a count up. Okay. Now another thing that's a little bit tricky here, how do I know I printed out 27 of these guys? Am I really positive I printed 27 and not 26 or 28? Remember we did these. Remember how over here it was kind of tricky whether I put a less than or greater than there, whether I started at 0 or I started at 1. You know, the fact that I'm doing 5 here means I had to be very careful where I started, where I ended. Did I test with a less than symbol or a less than or equal to symbol? This stuff's tricky. Yeah, where did I start? 0 or 1? Where did I end? 5 or 6? Did I use a strictly less than or a less than or equal to? Because I could start here at 1 and go less than or equal here, and that's 5 times. I could do strictly less than with a 6 here, that's 5 times. I could do a 5 here with an equal sign and a 0 here. Let's see, no, that's no, then I need to do 4 here, that's 5 times. See how many ways I can do 5 times? Yeah, there's a lot of ways of doing 5 times, and these are called off by 1 problems. is this 5 times or 4 times? You know, is it 5 times or 4 times? Now it's 4 times. Now it's 5 times. Now it's back to 4 times. Okay. These things can be hard to read. Okay. What about this one? What do you think? Am I really doing 27 highs? I can count them, but what do you think? Am I really doing 27 highs? Try something simple. If that's 27, this should be what? How many highs should this one do?
Two.
2. Well, that's easy to check. There they are. Okay. And okay. That's easy to check. I think that's 5. 1, 2, 3, 4, 5. Okay. So now I'm pretty sure that that's 27. Okay. I'm pretty sure that's 27. On your hand, suppose I had done this. Well, suppose I did that. And I'm not sure if that's 27 or not. Okay. So go here. Okay. Is that 2? I mean, count down to 1. Okay. Compile. Run. Wait a minute. I didn't get 2 outs. I got 1 I because I put a strictly greater than here. I was going from 2 to 1, but I didn't get 2 outputs because I stopped. Notice that this is strictly greater than 1. So the last time this was true was when counter was 2. So I went 2 once, and then that stopped. Okay. So if I put 27 here, and I naively think that that's 27 times, notice it's not going to be so obvious now. That's not 27 highs. It's actually 26 highs. Okay. It's actually 26 highs. Not, and then counting them is not so easy. It's very easy in this world to be off by 1. And notice if I just Google, Wikipedia even has a Wikipedia page just about off by 1 errors. They are so ubiquitous in programming to be off by 1 in a loop. Now we're about to start talking about the for loop. Okay, so it doesn't matter if it's a for loop or a while loop. It's so easy to be goofed up about, is this one really 27 or 26, or is it 28 loops? For example, now it's actually 28. Okay, but now it's 27. Now it's 26. Okay, but it's not that 1 is wrong here, and it's not that greater than is wrong here, because I can make it right with a 1 there by making it greater than there. I can make it right with a greater than there by making it let's see, I've lost that. Which one's this now? Yeah, that's 27. Notice I can't say that 0 is wrong because it depends on what's here. And I can't say that 27 or greater than is wrong because it depends on what's here. This could be a 0 or 1, and this could be a greater than or equal to, and I have to have the right combination of them. To avoid this off by 1 error, I need the right combination of something here and something here. I can even start with 20. Suppose I want to loop 27 times. I could start with the number 26 here and count down to 0. And now I'm counting 27 times. Okay. And as you learn to read other people's programs, you'll learn that people do confusing things. Like they'll want to loop 27 times and they'll write it this way and just dare you to figure out that that's looping 27 times, not 26 times. Okay. And you might ask, why would programmers write code like that? And sometimes it's because they're in a hurry. They just write something that works and then go back and fix it. It just worked, so they didn't touch it. So you end up with stuff that looks weird. Like, that's looping 27 times. But, actually let's check it. Let's drop 20, just do 2. See what does this one do? So compile, run. See? Oh, no, I got 2. That was 2. Oh, that was, so let's see. That was 26 times. Let's see. Oh, I'm sorry. 27 would be, yeah, there. See how easy it is? See, I made an off by 1 error there. That one is 27 times. Okay. So go back to this. See, now I got 3 outputs. Okay. Even though I have a 2 here, because I put it greater than or equal to there, I'm actually doing, I'm looping 3 times, not 2 times. So this stuff, off by 1s are ubiquitous. And what you need to do is always think. Every time you write one of these loops, you need to consciously think that I got to make sure that I'm doing it the right number of times, that I'm not off by 1, that I'm not doing it 1 loop too many or 1 loop too few. And you need to do something to check that. Sometimes it's hard, it's actually kind of hard to tell sometimes if you're off by 1. Okay, so that's the hard part of while loops, is these, basically the hard part of them is knowing when you're off by 1. You have something you're testing for, and in the loop you have to change it. Okay, and then you go back up here, and then if you don't change the thing you're testing for, you won't loop. Oh, let me just show you another thing. I'm counting down. Count down from 10 to 1. Now, somebody looks at this and says, you're going to go 10 loops. But I'm not going to do 10 loops. Why not? How many times am I going to loop? How many highs?
You're subtracting counter by 2 each time.
Yeah, so how many times am I going to loop?
5.
Yeah, good. Yeah, 5 with a question mark. It's really tricky sometimes to tell. Is it 5? Is it 4? It's actually kind of weird. Let's try it here. Okay, compile, run. Let's see, what do we get? 1, 2, 3, 4, 5. Okay, we got 5 loops. Make that a 0. We got 1, 2, 3, 4, 5, 6 this time. We counted down from 10 to 0 by 2s. When we count down to 0 by 2s from 10, that's 6 counts. But if we counted down to 1, we had 5 counts. Look at this. Suppose I count down to 2. That one's still 1, 2, 3, 4, 5 counts. Okay, that wasn't 8. It was 5. 1, 2, 3, 4, 5. This stuff can become, if I want to give you hard problems and I want to stump you, I just give you problems like these. Like you put on a test a crazy little loop like this and just dare people to figure out how many times it runs without a computer, for example. And there's some really cruel professors who actually put problems like that on tests. They'll write 5 lines of code and say, how hard is it to read 5 lines of code? And then they'll tell you, how many times does this thing print out high? And they'll do something weird like start at 11, decrease by 3s, and check if this thing is greater than -2. And what you have to do is you have to count it yourself. You have to actually be a computer, and you start with 11, then you check if 11 is greater than -2. You subtract 3 from 11, you get 8, and you just step your way through it, usually using a paper and pencil and a little table, and you just count them. How many? You just have to. Now, if somebody says start with 100, 1,000, if you say that, now it's really hard because I can't do it with paper and pencil, and I have to actually somehow figure out a logical way to solve this problem. How many times does this loop? And believe me, those are hard problems. Those are you would fire somebody who writes code like that for you. If you had an employee who was writing code like this, you'd fire them. Okay, because this could be, you're starting at this funny number, decreasing. You're checking for a kind of a weird boundary. You're decreasing by a weird number here. there's a logic to that. It does something specific. If you work hard enough, you can tell me exactly how many times this thing loops, but it's really hard to figure it out. But people will write weird code like this. And yeah, if you do run across weird code like this, then you just try to find the person who wrote it and tell them rewrite it in a readable way. Okay, so while loops can be tricky. While loops can be hard like this. Okay, this is not so much an off by one problem. This is a problem of unreadable. The combination of your weird starting, a weird test, and a weird decrement just makes it unreadable, which is an important issue. It shouldn't be written in such a weird way. Okay, now that's a while loop. While loop is real simple. The while loop, or it appears to be real simple. Like I've just been pointing out, it's not as simple as it appears to be. But all it is the word while, some Boolean expression, the body of the loop, and that's it. The loop loops as long as it checks if this is true. If this is true, it does what's in here, goes back up. Checks if this is true. If it's true, does this, goes back up. It better be the case that this thing modifies this thing somehow. Because if it doesn't, then you have an infinite loop. All right. Now let's switch to the other kind of loop. Okay. There's something called a for loop. For loop is more complicated. It's written in like this. It's got, well, you have, initially it looks like this. Okay. And you might think, oh, it's going to be a lot like a while loop. And in here is the do this. Okay. But what goes in here is much more complicated than just a single Boolean expression. What goes in here are three things separated by semicolons. So there's three parts to a for loop. There's the part before the first semicolon, there's a part between the two semicolons, and there's a part after the second semicolon. This part here is called the initializer. The part in here is the Boolean expression, just like in the while loop. Okay, so this one is a Boolean expression, just like in the while loop. And then this one here is called the incrementer. Okay, which we use just abbreviate as inc, but okay, I'll leave it incrementer. Okay, so initialize, Boolean expression, increment. Okay, I'll just initialize, Boolean expression, increment. Okay, and some people think of this as test, use verbs. Initialize, test, increment. Initialize, test, increment. Okay, now here's how a for loop works. Oh, let me go up here. What if I wanted this while loop to run 5 times? Remember, we did our example. I say int counter equal, I'll start my counter at 1. Then I will check my counter is less than or equal to 5. Then down here, after do this, I'll say counter equal counter plus 1. Okay, we did that over here. That's how we did things like this time. That's how we got this thing to loop 5 times. Over here in dumb, that's how we got all these notice we got these various weird loops by starting out with some initial number, testing for some value on counter, and then modifying counter. Okay, that pattern of starting number, testing the number, incrementing the number, that's what the for loop is doing. What the for loop is really doing is this guy is that line there. The test expression is this part in here. And the increment is this last line here. And that's exactly how the for loop does it. Okay, the for loop literally is this in disguise. The for loop literally, well, I shouldn't say literally, there's one little catch we'll see later. But the for loop is essentially initialize, while, test expression, do this, then counter equals counter plus increment. Well, that's not really quite, I should just, actually, what I should type here is just increment. You do the increment step and then you're done. Okay, so you initialize, you do the initialize while test the test expression, do this, do the increment, go back around here, test the test expression, do this, do the increment. Okay, all right. So a for loop does the following. When you enter a for loop, you do this one time because it's at the beginning. You do this one time. Then after you do that one time, you test the expression. Then if the expression is true, you do this. After you do this, you go over here and do the increment. After you do the increment, you go back here and do the test expression. You never go back to the initialize. Okay, you never go back to the initialize. Okay, let me draw you a picture because I think this should be drawn as a picture. I think I can do this as a picture. Okay. Oh, darn it. There. Okay. Now, let me draw like little arrows. I'll use a. Okay. When you come into a for loop, you do the initialize first. From the initialize, you go to the test expression second. If the test expression is true, you go down here. That's the case of true. Okay. If the test expression is true, you go down here. Then from here, you go over to the increment. This is the flow. We call this the flow of a for loop. You go to the increment. After you do the increment, you redo the expression, the test expression. You're never going to get back to initialize. You do initialize once, test, go down here, do this, increment. Notice that you don't read this thing from left to right. Oh, one of the things I keep wanting to tell students is you're not in English class anymore. Just because we use English-looking things does not mean you read things from left to right. Okay, you read this as for, start here, do this, down here, go left. Okay, come in, do the initialize. Now, after you do the initialize, you don't go into the for loop. After you do the initialize, you do the test once. If it's true, then you do do this. After you do this, you do the increment, then you do the expression again. If the expression's false, I'm not going to draw because it really kind of mucks up the picture. If this is false, you go down here to the out. Yeah, you go out of the loop, just like with a while loop. Yeah. So when it's false, you drop out. Okay. So this is starting at the line just above. So this arrow starts at the line just above the for loop. So from the line just above the for loop, you go to the initialize. The initialize is almost always going to be something like int counter equals 1. You know, then you do the test expression, which would be this thing like that's inside the for loop. You know, be something like that, and then the increment will be something like this. Okay, so this while loop just becomes that for loop. Okay, think of it visually this way. Come in and do initialize once, then do test, then do this, then do increment, then do test, do this, do increment. Now, oh, there's the loop. See, there is the loop. The loop is increment, test, do this, increment, test, do this, increment, test, do this. There's the loop. Okay. Okay. So think of it. It's real nice. I think this way of thinking about it is this kind of a picture. I think really helps, especially when you're learning for loops. You should force yourself. when you see a for loop to, even use your finger or whatever, just make sure you realize you're doing initialize, test, do this, increment, test, do this, increment. And then the loop is over there, and you never go back to initialize. Only do it one time. Okay? All right. Now, if we go back over, let me close that because it doesn't compile. So like here, instead of doing that, I'm going to change it to a for loop. Okay, and then I don't want this. I'm going to change this guy to a for loop. So I'm going to say, now the thing about for loop is it puts this line of code, this thing here, and this thing here all in one place. So it's going to be, it actually ends up being much easier to read. For int counter equal to 1. I'm going to start with the counter equal to 1. Counter less than or equal to 5. Counter equal counter plus 1. Okay, there's my for loop. Okay, and all I did is I took what was the while loop. What was the while loop? I took the initializer, stuck it in that part of the for loop. I took the testing part, stuck that in the middle part of the while loop. And what was down here is the incrementing part. I stuck that in the third part of the for loop.
Professor, you have a semicolon and then a comma.
And that's thanks. Yeah, it's supposed to be it's 2 semicolons. Yeah,
Okay,
real easy mistake to make. Yeah, there's semicolons in both places. Yeah. So okay, and you don't need that space there. Okay, now if I compile this. Oh, now here's something. Now remember I said a minute ago that this and this are almost the same thing, but there is one tiny difference between them. In a for loop, when you declare a variable in here, that variable disappears when you get here. See this, when you declare a variable here, the variable is outside the while loop, so it still exists down here. So this variable that I initialize here exists down here. But this variable that I initialize here does not exist when I get here. So in my code over here, I was trying to print out what the counter was at the end, but counter doesn't exist after this brace here anymore. I don't have access to the counter anymore. So I can't print out what the counter is, which is one of the reasons, that's actually one of the disadvantages of for loops. When you have a for loop, you've put the counter inside the for loop, so it doesn't exist outside the for loop, so I can't print it. Okay, so that's the only difference between, that's the only real difference between a for loop and a while loop. See how this int counter is outside the while loop, so int counter exists outside the while loop. But here int counter is inside the for loop, so it only exists inside the for loop. It doesn't exist past that brace. That's called the scope of this initializer. The scope of this initializer is to here, and then it's gone. The scope of this variable here was your whole program, until you finished main. Once you declared this variable, that variable was there until you got to the end of main. Now we have a variable that dies on us. If this variable goes away, we haven't seen this before. This is a variable that goes away. It goes away when I get to here. So that's an idea called scope. The variable lives from here to here, then it goes out of scope and just disappears on us. So I can't use it down here. Okay. Now if I compile this now, it'll compile. Okay, and now I'm asking for, I think it was 5 numbers, 2, 3, 4, 5. Okay, see, I asked for 5 numbers. Okay, my for loop my for loop looped 5 times. And I still have all the same problems with off by 1. Those problems do not go away with a for loop. How many times does that loop? How many inputs am I asking for now?
4.
Let's see. How can we check? Count starts at 1. 1 is less than 5, so we're going to ask for an input. Then count is 2. That's less than 5, so we're going to ask for an input. Then count is 3. That's less than 5, so we ask for an input. Then count is 4. That's less than 5, so we ask for an input. Then count is 5. Well, that's 5 is not less than 5, so we don't ask for input. Yeah, so we ask for 4 inputs. Okay. So even though I went from 1 to 5, I really wasn't going. See, I was going from 1 to 5, but not including the 5. So I actually only asked for 4 inputs. How many inputs am I asking for now?
Five.
5. How many inputs am I asking for now?
6.
6. Yeah. The off by 1 problems do not go away when you use for loops. A lot of people think that for loops are easier than while loops, but unfortunately, that's not really true, because you could start counting at 0 or counting at 1, or you can start counting anywhere you want. Your Boolean can have a less than symbol, a less than equal to symbol, and then over here, if I wanted to, I could go up by 2s. Yeah. So you do not get rid of the off by 1 errors. Okay. Now, let me make it more real. Okay, go from 1 to 5. Now, see, this is kind of verbose over here. Counter equals counter plus 1. Since this is so common, this is where you use that fancy little thing that says just increment counter. That's what it was invented for. There's where you want to use it. You want to increment counter. That's the same thing as just saying counter equals counter plus 1, but it's so much nicer to just write counter plus plus. And in fact, you actually should write this. It actually runs a tiny, tiny, tiny bit faster if you write it plus plus counter. You learn why in a later course, but it turns out that plus plus counter is 1/trillionth of a second faster than counter plus plus. Okay. So now people actually usually use counter plus plus. For some reason, counter plus plus has become the more common way to write it. But it's actually, if you look deep enough, people will tell you that you really should write it this way. You should write plus plus counter. They do the same thing. Later on, we'll see that they don't do this. I'm sorry, they don't do the same thing. They do the same thing here. They do have different meanings. Plus plus counter has a slightly different meaning than counter plus plus. In this situation, the meaning is the same, but one of them is a tiny bit faster. They mean the same thing here. They mean add 1 to counter, and this one is a tiny, tiny, tiny bit faster. Okay. And in some situations, when you use these two, you actually need to know which one you want. Sometimes you want one, sometimes you want the other. This one's always the faster one, but it's not always the right one. Here, it doesn't matter which one you use, except this one's a tiny, tiny, tiny bit faster. Okay. And there's actually another one of these. So remember, I could do counter equals counter plus 1. Okay, that I would abbreviate to counter plus plus or plus plus counter. What if I did this? Okay, you don't do counter plus 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 plus. That doesn't work. That's not going to give you 2. Okay, and if you put parentheses around it, it still won't work. That's not going to do 2 increments. But there is a shorthand for it. There's a nice shorthand for, there's a nice shorthand for counter equals counter plus 2. Okay, the way it looks like is you take the plus 2, okay, you kind of move them over here, and you put, well, you get rid of this counter. It's a little bit weird to read. You write counter plus equal 2. So you're saying let counter be 2 more than what it is. And you can't write it equal plus. That doesn't work. That won't compile. It's plus equal. That adds 2 to counter. Now you could do this, that adds 1 to counter. So that's another way of writing increment counter by 1, but usually people would just write counter plus plus. They won't write counter plus equal 1, but this you can do plus equal 3. You can decrement by that. Plus equal -1 is going to decrement by 1. That's going to decrement by 2, but if you want to decrement by 2, you could just write minus equal. Okay, so the minus equal, the plus equal, the plus plus, those were invented for making your for loops a little bit more easy to read. Okay, so these symbols were invented pretty much to make for loops easier to read. Okay, so counter equals 1, counter less than 5, counter plus plus. Start with counter 1, do that one, make counter 1, that starts you off. You do that just one time. Then check that this is true. You always have to check that first. Do what's in here, then increment the counter, and then go check the counter again. Okay, and you still have to worry about off by 1 errors. For loops don't actually solve that. Let me show you another little thing. You're allowed to do the following. You can say for that's a legitimate for loop. Okay. What it does is it's got an empty initializer. And it's got an empty incrementer. And it's got the Boolean expression. Does anybody see something? Now think about it. What does this do? It's going to skip over the initializer and do the Boolean expression, do this, skip over the incrementer, do the Boolean expression, do this, skip over the incrementer. What is this for loop the same thing as?
A while loop.
Yeah, for loops are actually while loops. This is a while loop. A while loop is nothing more than a for loop with an empty initializer and an empty incrementer. Okay, this is a for loop. This is a while loop. Okay, so now to do this, better change the Boolean expression. Okay, you will see people write this every once in a while. You will see people write this kind of thing. Here's another quirky thing. Remember, if we put while true, that loops forever, right? You can do the following. Now, empty initializer, empty test expression, empty incrementer. This loops forever. Now you can't make this guy empty. That won't compile. You're not allowed to make that empty. But you are allowed to make this guy empty, and it's treated as true. And these two are the same thing. You will see people do that little trick every once in a while. If they want a for loop that increments forever, runs forever, they'll write for parentheses, semicolon, semicolon, close parentheses, close parentheses, and then the down here, do this. Okay. All right. So these two ways to write an infinite loop. Okay. What's funny here is that you don't have to put something inside there. You can just write for parentheses, semicolon, semicolon, parentheses, and you don't have to write the true in here. For the for loop doesn't require it. Okay. So there's all kinds of for loops and while loops are actually, from the point of view of the theory of programming, for loops are just a slightly more convenient way to write while loops. They are not something different. It's just another syntax for writing a while loop. The only difference is, and it's an important little difference, the variable you put here ends here. Where with a while loop, you have to put the variable before the while loop, so the variable is over here. It's still there. because it's outside the while loop. But if you put a variable here, if your initializer creates a new variable, that variable scope ends there. So that's the one thing that makes a for loop different than a while loop. That if there's something in the initializer, then that variable that's declared in there ends there. Now, some people will, let me show you one last thing. Some people, to get around that problem, don't declare the variable in the for loop. They make it kind of while loop like. They put their counter outside, the declaration is outside the for loop, then the initialization is inside the for loop. But now I could print out the counter down here if I wanted to. Oh, and I got to close this guy. Sometimes people, because they want that variable outside of the for loop, they do like a while loop. They declare it outside of the for loop. They declare it outside the for loop, then initialize it inside the for loop. Most of the time, you don't want to do it that way, but you can do it that way if you want. It's more common to just do it like that. Declare the variable in the for loop, but then the variable has to die. You know, then a variable dies here. Okay. All right. So we've run out of time. Okay. So now we've got an introduction to everything we've talked about today. Is just how do you write a for loop? How do you write a while loop? We haven't really said anything about how do you use them. Using them is tricky. We want to really start talking about how to use them to solve real problems. And that's where next week we'll talk about this section on for loops and strings, because that's where you start using them to actually solve nice little problems. And that's where CodingBat has lots of nice examples too, of how can you use a for loop to actually solve a little problem. It's one thing to just know what the syntax for a for loop is, just to know this syntax. It's another thing to actually use it to solve problems. So all we've talked about is what it is, not really said much about how do I really use this to solve problems. So we'll start with that next week. We'll start solving problems with for loops. Okay, anybody got any question? Any question before we go?
Nope.
Okay, so stop sharing. And then we'll remember we meet again a week from today. So you have a vacation, have a nice vacation, and see you in a week. Bye-bye.
All right.
Bye.